Welcome to question 5 of the 2015 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. For question 5 we're told that on any given day the depth of water in a river is modelled by the function h of t, which is equal to 14 plus 8 sine of pi t on 12, and it has a domain of 0 to 24. Where h is the depth of the water in metres and t is the time in hours after 6 am. For part A, we're asked to find the minimum depth of the water in the river. So the minimum depth is going to equal the 14, which is the middle of the function, it's the translation in the positive y direction. Subtract the amplitude, which is how far the function goes above and below that middle value. So we have that is going to equal 6 metres. So that is the answer to part A of this question. From the examiner's report we can see that 69% of students got that mark and that the question was generally well handled. Common errors included finding the maximum height rather than the minimum, having negative signs by calculating 8 subtract 14 rather than 14 subtract 8, and evaluating h of 10. Students who used calculus to obtain a minimum value tended to make careless errors in the differentiation and altogether would have taken longer to answer this question than knowing the shortcut of taking the middle value of the function subtract the amplitude. For part B we're asked to find the values of t for which h of t equals 10. So h of t equals 10 is the same as 14 plus 8 sine of pi t divided by 12 is equal to 10, and then what we're going to do is we're going to subtract 14 and we'd get 8 sine of pi t over 12 equals negative 4, and then dividing by 8 just gives us sine of pi t divided by 12 is equal to negative a half. So now that we have the trigonometric function by itself, we can think about the unit circle and where sine is equal to negative a half. So we know that sine is read off the y-axis and the pattern goes root 1 on 2, root 2 on 2, root 3 on 2. So to get to a half we need the pi on 6 angle. So that will give sine being negative a half in these two quadrants. And as it takes pi radians to get halfway around the unit circle, we can write this as 6 pi on 6. And this would be 12 pi on 6 once you do a full cycle. So we are pi on 6 further around, so we know that we need the part inside sine, which is pi t over 12, to equal 7 pi on 6. And we also go pi on 6 back from 12 pi on 6, which is 11 pi on 6. Next, if we multiply each term by 12, we get pi t is equal to, and that would just be 14 pi, or 22 pi, and then dividing both sides by pi to get t by itself, we would have t is equal to 14 or 22. And now inspecting our domain, we are finding t values between 0 and 24, and 14 and 22 both fit within that domain. And just as an extra check, we're going to calculate the period of this function. So we know the period is equal to 2 pi divided by n, where n is the coefficient of t, so in this case n equals pi over 12, not just pi. So the period is going to equal 2 pi divided by pi over 12. And now instead of dividing fractions, we could do 2 pi over 1 and then multiply by the reciprocal, which is 12 over pi, which gives 24 as the period. And in one period, we'd usually expect two solutions. So these are the correct values for part B of the question. From the examiner's report we can see that 53% of students got full marks for this question and that the question overall was well handled. So most students were able to set up an equation that when solved would yield the two correct answers for the restricted domain. Some students did not recognise the base angle of pi on 6. And my recommendation would be to use a unit circle to help identify which angle you're interested in to generate solutions from.